Hello and welcome to Buar Academy. Statistical quality control and control charts. And in control charts, let's now study P chart. Yes, P chart is one of the control charts for attributes. Here in this case, we cannot measure the units which we have selected in each and every sample. It is not, say, feasible or possible to measure each and every unit of the sample with respect to our definition of defect or, say, presence or absence of a particular characteristic. In this case, we just study every unit in sample with respect to presence or absence of the predetermined characteristic. That is defined as defect. Either presence of the characteristic is defined as defect or absence of the necessary characteristic is defined as a defect. And we inspect each and every sample with respect to this definition, yes or no, defect is there or not. So we actually segregate the whole sample into two categories, defective units and non-defective units. So we have taken 12 samples in this example, each of size 200. Okay, and out of 200, in first sample 22 units are defectives. In second sample 16 are defectives out of 200. Similarly, in case of sample number 3, 18 are defective out of 200 and so on. Total we have taken 12 samples of 200, that means total we have drawn 2400 units for inspection, out of which total 220 are found to be defective. This is the whole scenario. Now, in case of P chart, we can construct P chart in two forms. One is directly the proportion of defectives, and another variant that is not actually more popular. Some authors ignore to discuss that variant, but it is a very important variant, and that is percentage defectives variable. Rather, percentage defectives, the meaning of P is here proportion of defectives in each and every sample. Another meaning is percentage of defectives in each and every sentence. Nothing new, only this proportion is multiplied by 100. Irrespective of sample size, it is multiplied by 100. Then we get the percentage of defectives in each and every sample, and we go ahead with the help of these percentages. But that I shall discuss in the next lecture. I personally believe that there is no any important difference between proportion of defectives and percentage of defectives. But in case of a special circumstances where the sample size is not equal, I personally recommend the percentage of defectives chart. Okay, it is under our control to keep the sample size equal, but sometimes if it is not possible to keep the sample size equal for all the samples and we have to draw samples of unequal size, then we cannot draw, or rather it is not advisable to draw or to construct the proportion of defectives chart. Instead, go for percentage defective, but we shall discuss it in further lectures. Let's concentrate on proportion of defectives. These are the proportions of defectives in all the 12 samples. 22 out of 200, that means 0.11 is the proportion of defective in sample 1. Similarly, 16 out of 200, so 0.08 is the proportion of defectives, and in that way I have already calculated proportions of defectives in all 12 samples. Okay, this is necessary because we plot the proportions of defectives in our control chart. That's why it is called P chart or proportion of defectives chart. Okay, now what? First of all, we know that The sample size is 200 for all samples. Total for 12 samples comes to 200 into 12, that is 2400. That we shall use to calculate P bar. Sigma NP, that is total number of defectives in all the samples. Yes, that is 220 here. So we can calculate P bar, that is sigma NP divided by sigma N, that is 220 divided by 2400, that is 0.0917. So if we round it off in 3 decimal places, because third decimal we can show on the millimeter line, our P bar comes to 0.092. But in further calculation we shall use this value, and this becomes our central line. Okay. Now it is turn of calculating upper control limit. As in case of mean chart and range chart, we know what is upper control limit and lower control limit. In case of P chart, the upper control limit, please write the title upper control limit first and then only use this short form. The formula is P bar plus 3 into under root P bar into 1 minus P bar upon N. So that is 0.0917 plus 3 into under root 0.0917 into 0.9083 divided by 200, individual sample size. That is 0.0917 plus 3 into under root. Yes, simplification of this fraction actually comes to approximately 0.000418. So it will be 0.0917 plus 3 into, now square root of this gives us 0.02045. 0.0917 plus 3 into that is 0.0613. Rounded off figures are there, and therefore upper control limit of this P chart comes to 0.1530. Yes, here also we have 3 decimal places because the third will be placed on the millimeter line. Okay, now lower control limit of P. It is very easy because just sign from plus to minus. That's the only required conversion in the formula. P minus 3 into the same formula, under root P bar into 1 minus P bar upon N. We know the value of this factor. So it is 0.0917 minus 0.0613. So it comes to 0.0304. Therefore, lower control limit we are going to take as 0.030 because of our limitations of the graph paper. We can take anything up to millimeter scale only. Okay, so first, in any examination, in a problem, you will find this readily available in the question or your problem. Yes, sample size may not be given in the columnar form. The examiner has a choice to express the sample size as just as an information, 12 samples each of size 200, etc., etc. But it should be there in the problem. This should be clear. Number of samples should be clearly stated. Number of defectives should be clearly given. The solution part starts from preparing the column of proportion of defectives, and in case of another variant, percentage of defective, that we shall discuss later. Yes, after calculating P, or rather preparing the column of P, proportion of defectives, first write common sample size, then summation of all the sample size of all the samples, that is nothing but common sample size into number of samples. Yes, then find out the summation of NP, that is number of defective units in each and every sample, summation of that. Okay, yes, please be careful, no summation should be wrong, otherwise everything will be wrong after that. Yes, P bar is sigma NP, that means summation of number of defectives in all samples divided by total number of articles in all samples. Yes, that is average proportion of defectives in this particular study. That becomes our central line. Then on the basis of this we can calculate upper control limit and lower control limit. Now we have upper control limit, lower control limit and central line. So we can plot these on graph paper. Okay, for that purpose I will have to abolish all these things from the board and I will have to rewrite the column of P and R three results. Okay. P is 0.11, 0.08, 0.09, 0.07, 0.19, 0.15, 0.10, 0.18, no, 0.015, sorry, 0.10, 0.18, 0.13, 0.04, 0 and 0.095. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay. N 200, sigma N. Okay, this is just a summary. Sigma NP not necessary for preparing the chart. P bar we calculated it as 0.0917 and we are going to take it 0.092 because of limitations of our graph paper. Okay. So our central line came to 0.092, upper control limit came to 0.153 and lower control limit is 0.030. Okay. Now we are in a position to draw the control chart, P chart or control chart for proportion of defectives. Yes. You can see the limitations of using a duster. But we have to bear something. But I always like a chalkboard against a whiteboard and using that, sticking black pens. Okay. Oh, that is my personal limitation, I think. Yes, as usual, x-axis and y-axis. X-axis stands for sample number and y-axis stands for proportion of defectives. Yes, proportion of defectives. Proportions rather. In short, they are P. Okay, we have 12 values and the lowest value is 0 and the highest value is 19. So from 0 to 19 we need 0 is here and now 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. Yes, 0.01, 0.02, 0.03, 0.04, 0.05, 0.06, 0.07, 0.08, 0.09, 0.10, 0.11, 0.12, 0.13, 0.14, 0.15, 0.16, 0.17, 0.18 and 0.19, that is the highest value. Okay, now sample number on x-axis. Sample number. They are 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 and 12. Yes, on both the axes, try to maintain the difference of 1 centimeter box only. Yes, that makes easier to construct the chart. Because in case of sample error, we don't need more space, and here you can use the technique of pulling. Yes, technique of pulling. If we have lowest value 0, so we need to write all the numbers. See, if the lowest value is something else greater than 0, say for example it is 0.06, then you can pull the y-axis and start writing directly from 0.05 or 0.06. Yes, it is always allowed, particularly in this type of cases. Okay, now the central line, that is 0.092. 0.092. You have to leave 2 millimeters above 9 on your graph paper, mind well. Yes. Central line is always drawn continuous. Upper control limit is 0.153, 3 millimeters above 0.15 rather. And upper and lower control limits are always shown as dotted lines. And similarly, lower control limit is 0.03. Yes, dotted line again. Upper and lower control limits are shown as dotted line. Please remember, all these small things are important as far as your examinations and marks are concerned. When you have written perfectly or shown everything perfectly, we as a paper checker try to find these kinds of faults. Yes, okay. Mind well, I am not doing that thing, but it is necessary. Whatever we do should be, say, as perfect as possible. Okay, now plotting. Okay, first is sample number 1, 0.11. Sample number 1, 0.11. Okay. Sample number 2, 0.08. Sample number 2, 0.08. Sample number 3, 0.09. 0.09, almost below the central line. Then sample number 4, 0.07. 0.07, sample number 4. Sample number 5, 0.19. Yes, please mind well, or remember, for me, on this kind of boards, it is possible to draw a sketch of the chart or graph only. You people must use the proper graph papers, having boxes for millimeters as well as bold boxes for centimeters. Yes, and you need to do these things as clearly as possible. It should look decent. Yeah, sample number 6, 0.015. 0.015, yes, between 1 and 2. 0.015. See, this is below the lower control limit and this is above the upper control limit. So now we know that the process is not under control, but we need to complete the chart. Sample number 7, 0.10. Sample number 8, 0.18. 0.18, sample number 8. Sample number 9, 0.13. Sample number 10, 0.04. 0.04 above the LCL. Point number 11, it is 0. And point number 12, it is 0.095. Yeah, okay. Here it is, between 9 and 10. Now, there are two ways, either to join all these points with a line or not. I leave it to you. Some teachers prefer that you join all these with a straight line, but it is not compulsory. Yeah, I sometimes do it, sometimes not. When I was studying, me or my teacher had not done ever that thing, because we are actually interested in observing that whether any one or more sample points are below the lower control limit or above the control limit. If yes, the process is not under control. If all the sample points are within upper control limit and lower control limit, primarily we mean that the process is under control. So I leave it to you whether you join the sample points or not. Okay, now see these 4 points. What is special in these 2 points? In case of these two, they are above the upper control limit and these two are below the lower control limit. So out of 12, 4 points are not within the upper and lower control limits, too high proportion. Yes, 1/3 of the sample points are out of the above or lower control limit. So it is the clear-cut case of a conclusion that the process is not under control. So you must write your conclusion that this process is not under control because 2 sample points are above the upper control limit and 2 sample points are below the lower control limit. If only 1 sample point is either below the LCL or above the UCL, we conclude that the process is not under control. We ought to be stringent because from a very large population of the production, we have selected only 12 samples of size 200, and on the basis of that we need to conclude about the whole process for a specific period of time. So we must be stringent, we ought to be stringent. Okay, so this is a very simple case of P chart. In this case, the meaning of P is proportions of defectives. Yes? Okay. I hope this lecture proves to be useful for you people to understand everything regarding P chart. Please don't forget to like this lecture, all my lectures. Please visit my channel and subscribe, and please recommend my channel to all others, students as well as their parents. Here something important is for all who are interested in studying. That's it. Thank you very much.